Forge hotter, you get much more movement than forging colder. How it might move away from the edge, but in general, we should get close to 4 inches, which is more than enough. The loop for this, from the back to the tip, 3 to 4 inches, whatever works best. So just like the nail, except for the point, we're not going to put a point on this first. That material is isolated. Remember, you isolated it using the corner of the anvil. You pushed in 2 adjacent shoulders to it. So we're going to do the exact same thing, but only with 1 inch of it. So that's going to be a guiding line. So half face blows right on the corner, 2 adjacent sides. Really hot. Strike very hard when it's its hottest. So just come up to this, bring your hammer down, then turn, then back to the initial one. So producing 2 adjacent shoulders. Now we've isolated this material from the bar, and that's what's going to be the long part for the lever. So now we have this big lump to work out. We want to work it out quick. You could continue to work it like you worked a nail, all on the flat of the anvil, but I want to introduce a more efficient means of moving that. And I want you to think about the contact of the tools to the material when you're working. When you have a relatively flat surface such as a hammer and an anvil, you're making contact on all parts of the metal at once. So the power input is spread over everything. So I want you to consider moving to an area that has 1 point of contact. So if we look at your crossbeam hammer, how narrow that is in relationship to the face of the hammer. If we look at this and think of this as having 10 units of pressure given this area, and then we look at something that's just a 1/4 of it with the same hammer swing, you could have almost 4 times the amount of force on this area than that one. So the same is true for the horn. There's 1 point of contact, a tangent on a circle, versus a plane. So that force you're putting on there does much, much more work. Keep your shoulders pointed down. Swing a little slower, but more deliberate. Give yourself time to turn. Stop when it's still hot enough to straighten out. So what was 1 inch is now 2 inches in one heat because of the power of this small point of contact. It's going to indent it differently. So you hopscotch between the horn and the face. The horn will move the metal. The face will clean it. So you can come down and organize the surface and the shape. Keep it straight. So again, you're just turning to adjacent sides. If this had a bend in it like that, you have to move your hand over this way and then move your shoulder up and then back down, so it moves your mechanics around a lot. If you keep it straight, all you have to do is twist your... Almost finished, just a little bit longer. Now I'm thinking to bring the the end to a point because that's going to be a curl. And I'm not keeping 100% tally on the length of this. Here I'm crashing corners. You could make it round or you could keep it square or octagon shape. But that's our first step. That's going to be the lever and the ornamental finial on the end. So it's essentially just like you did with this. So this is going to be bent away from the shoulder. I want to space the shoulder. Let's see the shoulder spaced away from the vise. Okay, so that would be step one. And this little lump we want to address next and forge that lump down. So it's almost or laying down. You just want to tap that curved area down like that. To remember the physics involved in what you're working on, and that's the rebound we have. The rebound coming off the anvil is a good indicator of where to keep that hammer head. Pulling it out of the region of that rebound zone wastes energy. When we're doing heavy forging, we want to lift the hammer up a little higher, let it develop, give it time, let it develop that velocity with the limited amount of mass we have. Initiating the swing is mostly elbow and shoulder. If I had my way, I'd tell you don't move your wrist at all. Keep your wrist steady throughout the range of that motion. And even if you want to take some time and kind of put your fingers on your hand and your wrist, make sure it's not doing this. This is going to hurt. There are times when you will do this, but it's very light. When you're surfacing something, when you're adjusting something, you can move your wrist. But generally for forging, it's shoulder and elbow. Don't move your wrist. And try to keep the hammer at an angle across your palm, not 90 degrees to it. 90 degrees, when you come down this way, makes you break at your wrist. And if you notice part of your wrist coming forward, watch what happens when I let this go to an angle in my palm. My wrist starts to straighten out. So it's a hand hold with the thumb across the palm, not 90 degrees to it. Like, think of maybe pulling a rope on a bell, like that. So I'm just coming right down on this, only going to the thickness of that prong that's right there. So you want to bring that down to about even thickness. It's at this point you could kind of come in and push this back against itself a bit, a process we call upsetting. So I might just take a quick heat at the vise to push that metal in there, creating a flatter platform to push that tooth into. In there. But as an exercise to teach people, it's difficult to. All right, that's all. Just to kind of flatten this flow. The tip of the horn is going to forge that indention for us. We could also try it on the corner of the end. So we have a very finite pressure spot that's going to do the forging for us. So either one of those. We only just need the semblance of a little bit of a ledge. You guys look at this and feel this. Just need to pull out a little bit of a... So I'm going to steady myself with the hammer, put that on there like that, give it a blow, turn it over and look at it, which is kind of hard to see, but you can see now that it's cooling the little indentation. That's tactile to you, which means you can feel it. So you can come back here, confirm it. You can even see the end starting to move. So we'll get it hot again. Now that we've got a good footprint, we can get the work done a little better. And you just have to pull it out thin. Just simple. So I'm just going to drop the hammer down lightly. Not going to pound the daylights out of it. Just a little bit. Then the rest of it is putting a volute on this and curling it around. So we'll do that. Curl it this way. But in its orientation, we can't get to that. We can't kind of, this is very awkward trying to roll that way. So, you know, those that know the least sometimes see the most. So he's like, well, why don't you just turn it forward? So we're just going to put it in the convenient area. So now we can have that in line and we can do our volute.
Trixie.
Remember the management arm to spin that around. Depending on how long yours is, you could roll that up more. So now we just continue bringing this around. We want this straight section to be across from the tooth. A situation called column strength. So anything in column means standing. As you put pressure on the ends, within a certain proportion of thickness to length, it's going to buckle. And so we want to optimize what we want to get done by not having too much sticking out. So with half-inch square, you really can't have more than an inch sticking out of the vise, or it will buckle. And in a small piece such as this, a lot of buckling will be hard to control. You also want to grab it in the middle of the vise because that holds it the best. And as it cools, you have to tighten it a bit. Move around and hammer all sides equally. You still may experience a bit of buckling. In a perfect world, turning it to a different position in the next heat would be very helpful. So you can see as it starts to thicken, it did buckle off to the side. See how it's buckling off that way? So that should be mended by placing it on the anvil and just kind of reestablishing the trueness, kind of reposition it. Lots of fun opportunities for creativity. Anything that's going to be in somebody's hand. And as all objects we make take more form, they continue to get trickier and trickier to hold on to.